Welcome to the Radar Grid. I'm your tower director for this Cambridge AS and A-level mathematics simulation. Today, we're running an elite-level explainer on Probability and Statistics 1, specifically mastering the absolute chaos of permutations and combinations. Imagine your exam paper as a crowded airspace. You've got high-stakes questions coming in fast, under extreme time pressure, and it is entirely up to you to guide them to a safe touchdown. We are going to look at exactly what the senior examiners, the aviation inspectors of this scenario, are looking for. No textbook fluff today, just the raw, underlying logic you need to confidently manage these high-stress mathematical scenarios without crashing your grade.
Let's look at the payload we're dealing with today. 15. That number is absolutely critical. Permutations and combinations account for roughly 15% of your total marks in Paper 2. In air traffic terms, this topic is an incoming heavy aircraft. It holds massive weight, and if you mishandle the underlying logic, it will severely impact your overall A-level grade. This isn't just a minor blip on the radar. It's a high-tariff operation. We have to secure these marks efficiently, accurately, and before the fuel, your exam time, runs out.
To handle this airspace safely, we've broken our flight plan into 6 distinct vectors. First, we'll establish that 15% advantage, then lock down the core principles. From there, we move into the standardized sequence, deploy the ultimate method mark safety net, clear out top examiner warnings, and finally, look at the evaluation insights that secure a perfect landing.
Initiating Phase 1, the 15% advantage and unlocking the true value of Paper 2.
So why do so many students completely lose their bearing when applying math concepts to unfamiliar contexts? This is the exact question senior examiners ask when they're reviewing the crash reports of past papers. Stepping outside memorized examples is where the real stress test begins. In our simulation, let's picture 2 typical radar operators, Router Alex and Router Sam. When faced with an unfamiliar scenario, Alex gets totally bogged down in minor details, overthinking whether it's an NPR or NCR situation, and essentially puts the question into an infinite holding pattern until the clock runs out. Sam, on the other hand, clears the answer for landing way too fast. Sam rushes the calculation without checking the structural safety regulations, like whether order actually matters. Both approaches lead to panic, misapplied formulas, and lost marks.
Moving to Phase 2, Core Principles and Domains, or how we move beyond simple rote memorization. To stop making the mistakes that Alex and Sam make, we need to map out our approach layout based on explicit assessment objectives. The examiners are targeting very specific cognitive domains. They are pushing you to rely on established principles rather than just taking a wild guess in the dark. Let's break these down into mathematical operations. Knowledge is simply knowing your fundamental formula. Application is your skill in plugging the correct variables into that formula. But systematic analysis, that is the higher order skill. That's taking a complex, multi-layered word problem and breaking it down into actionable, safe steps. If you skip the systematic analysis and just start crunching numbers like Router Sam, you are guaranteed to miss critical constraints.
The radar controllers, the examiners, are actively looking for top-performing students who exhibit a connected, conceptual understanding that transfers seamlessly to unfamiliar contexts. When the exam throws a massive curveball at you, like a seating arrangement problem where 2 highly volatile people absolutely refuse to sit next to each other, you can't freeze up like Alex. Instead, you need to transfer those core principles to systematically break down the constraints, calculate the total possible arrangements, subtract the restricted ones, and confidently guide that solution right onto the runway.
Take a close look at this cognitive domain grid, because it brilliantly illustrates the exact sequence you need to scale up your skills. Knowledge is just your baseline proficiency, demonstrating mastery of those fundamental combinations and permutations. Application requires using the correct formats and mathematical terminology. But analysis? That is where the elite candidates pull ahead. You have to be able to extract the exact variables from dense, confusing text blocks and interpret those mathematical relationships flawlessly. That is how you clear an argument for a safe landing.
Entering Phase 3, the standardized solution sequence, which is your 5-step procedural framework.
Tower transmission check. Before we clear this next response for touchdown, I need to ensure your transponder is fully updated. Hit that subscribe button for Ace the Exams right now and turn on all notifications so you never miss an emergency briefing. Okay, transmission verified, let's resume. To prevent the infinite holding patterns we talked about, you need this 5-step procedural framework. It is an incredibly reliable safety net. Step 1, identify the key elements. Step 2, apply the relevant principles. Step 3, execute your analysis with crystal clear working. Step 4,
Verify the results against the problem's constraints. And step 5, present your final answer in the appropriate format. That very first step, identifying those key elements to determine whether order is actually important, is the most critical hurdle in permutations and combinations. If you misread the radar there, the entire sequence crashes.
Transitioning to Phase 4, the method mark strategy. This is your ultimate safety net. I need you to burn this amber warning light from the principal examiner reports straight into your memory. Students lose marks constantly by not showing their working. Under intense exam pressure, when the clock is ticking down, simple arithmetic errors happen to the absolute best of us. You might multiply when you should have added, or you might completely drop a digit. Listen carefully. The method marks are the emergency foam on the runway. They are built into the Cambridge grading system to reward your conceptual understanding, meaning even if your final calculation goes slightly awry, you can still survive the landing. Your process is just as valuable as your final calculation.
Let's look at this comparison side by side. If you just slam down a final incorrect number without any context, the examiner has zero idea what altitude you were flying at. That gives you a flat 0 marks. But let's say you encounter an unexpected structural block mid-paragraph. If you write out your clear working, documenting exactly that you are multiplying 8 choose 3 by 5 permute 2, even if you fat finger it into the calculator and get the final number wrong, you still secure the vast majority of the marks. Why? Because the examiner can read your flight data recorder. They see your logic. They can verify that you chose the absolute correct mathematical procedure for the context. Your written working is your definitive proof of understanding. Now for Phase 5, the top 3 examiner warnings. Let's clear the debris on the runway and avoid common pitfalls.
This is our interactive runway workshop. We need to isolate exactly where students are bleeding points unnecessarily. The examiners have flagged 3 major hazards. Hazard 1, confusing cause and effect. We see this all the time when students mix up dependent and independent events in a probability matrix that relies on combinations. Hazard 2, failing to follow strict structural conventions, like clear annotation or leaving answers in unsimplified formats. And Hazard 3, providing generic answers that completely ignore the specific context of the given question. You must tailor your combinatorial math exactly to what the scenario dictates, otherwise you are violating safety regulations and dropping massive points.
When the adrenaline spikes during an exam, your working memory drops fast. To avoid getting tangled up in that panic, you need systematic memory hacks. Create your own mnemonic using the first letters of key terms to lock down your terminology. Relying on a rigid step-by-step mental checklist significantly reduces your cognitive load. Instead of freezing up over a highly complex, unfamiliar scenario, you just systematically run down your procedural steps. You isolate the variables, check your mnemonics, and ensure your mathematical analysis stays perfectly on the glide slope.
Entering our final phase, number 6, final evaluation insights and securing the highest possible marks.
Let's look at how the tower directors evaluate your higher-order skills to clear you for those top-tier A-star marks. The grading framework actually scales up through 3 distinct altitudes. The descriptive level is just naming the parts and identifying basic elements. The analytical level is showing how the permutations or combinations actually interact within the engine of the problem. But the evaluative level? That is where you justify exactly why you chose a specific combinatorial approach over an alternative one. If a problem is complex and multi-layered, demonstrating that elite evaluative understanding is what logs a successful full-mark landing sequence.
When you are tackling these high-tariff questions, you have to prove that you can spot limitations and assumptions from a mile away. You need to understand exactly how those factors alter your final conclusions. For instance, did you assume replacement when the mathematical constraints clearly dictated non-replacement? Did you consider alternative interpretations of a really challenging text map? Showing the examiner that you are actively tracking and assessing these specific variables proves you have a deep, structural understanding of the mathematics at play.
If your final answer is completely wrong, does your working paper tell the examiner exactly how you got there? Ask yourself this crucial question every single time you run a past paper simulation. If the answer is no, you are leaving your grade entirely up to chance. Remember our fuel to mark budget formula? Success in permutations and combinations is not just about crunching a number, it is about the flawless communication of your mathematical logic. The next time you face a tricky seating arrangement or a brutal probability matrix, ask yourself if you're just guessing or if you're building a logical flight path that guarantees full marks. That's a wrap on today's simulation. Do not forget to subscribe to Ace the Exams, enable the notification bell so you're ready for the next emergency drill, and leave a comment down below telling us which math paper gives you the most anxiety. Stay sharp, and I'll see you on the radar next time.